Good morning. Everyone is well? You've had your coffee? You're coming in? Very good. We have a lot of technologists here, yes? Everybody's wearing black, gray, or blue, except for a few of you. Oh, this one gentleman over here. So I think we'll wait a little bit. There's still some people coming in, but we do want to start pretty quickly because we have a lot of content and we have 2 hours. So we want to make sure that we give as much information to you as possible. We will hold questions until the end, okay, if you will. But also, I think our emails are both on this, I'm not sure.
On the
okay,
title
so,
slide, yeah.
Our emails are actually on the presentation. So if perhaps you have questions later on, you can send them directly to us. We would be very happy to hear from you.
We're also to be found at the IoT booth within the World of Solutions.
Yes.
I'm usually at the manufacturing or one of the industrial vertical areas, and Robert's with the security.
Okay. Very good. All right, tell you what, why don't we go ahead and get started? And we push the buttons. Very lonely in this WebEx Teams group right now? No? I see. Bien. Very good. Thank you. Yeah, we're supposed to do this. It's not happening. It's okay. You're not hurting my feelings. Okay, so here we are. We don't have the email address. So I'm Robert Albach, product line manager. I'm in the security group. I used to be in the IoT group, did some work. Now I'm back in the security side. And this discussion is about IT and OT. In some ways, I am going to be representing the IT perspective because that's my job.
My name is Paul Didier. I'm in our IoT business unit in our solutions group. I'm a solution architect. I've been building solutions in this space for the last 12 years, pretty much when I started with Cisco. Most of my focus on manufacturing, but I've done a lot of work in utilities, oil and gas, and to even some extent transportation, rail, and some of the other verticals that we support as part of the IoT portfolio. I represent Cisco within the ecosystem and work with a lot of partners, and I'm going to be playing more the OT role, trying to explain to you guys how some of the systems and technologies work and the security perspectives based on that.
Right. So it's very purposeful that we have myself representing the security group, focused on the industrial space, and Paul from the IoT group, because a big part of any security discussion has to do with process, and a lot of it has to do with culture. And what you might often find is that there may be a cultural conflict between the IT group and the operations team. Paul and I get along very well. So you can maybe do the same. I married a chemical engineer. We get along reasonably well. We have 3 children. Production's okay. Quality, we'll find out in a few years. But this is a big part of the discussion. And so I'll make this statement many, many times. Security is 90% process, some percentage of the products and tools that you use, but that process is going to have to involve the people in the operations group. So let me just ask here, how many of you in your organization, you're located in the IT group within the organization? Okay, so that's the most of you. You're at Cisco Live. Okay, not a surprise, right? How many of you are in your organization within the operations side? Okay, very good. How many of you are sitting next to an IT, OT person, as in you came here with your IT peer or OT peer? One of you, okay, all right. So you're in Barcelona, and your operations friends are still back in the factory. Okay, very good. So let's go ahead and let's move forward. Security. $8.5 billion were lost in public companies in industrial environments over approximately a 2-month period in 2017. There was no attack. It was a purely incidental infection. These systems are so inherently insecure that just an accidental infection caused this much damage. And this is a big reason why many of you in the IT group are necessary to make things better. Specifically, these types of activities took place. These 5 companies alone lost almost $3 billion US. This is the most expensive cyber incident ever. And in no way was it targeted, except for one small group, and these people were collateral damage. I'm going to spend a little bit more time on this later in the presentation, but these are the big points to make. Help is absolutely needed, and you are the first step to actually getting there. Things happened continuing in 2018. Boeing, not exactly a security or technology neophyte, also hit. We have some interesting geopolitical activities going on. And Triconics, anyone familiar with Triconics? Know what that is? Okay, this is from Schneider Electric. It's a safety instrumentation system. For the first time ever, somebody attacked a safety instrumentation system. The damages were minimal. In fact, if you were to compare it to the accidental infection that shut down 25% of the world's shipping, it was almost like you couldn't even possibly compare it because it was so small. But that's the only publicly known attack on an industrial piece of equipment directly. Yet we always focus on the things side. And this is one of the things that we're going to help you understand a little bit differently. So what is it we're going to focus on? So the goal of this presentation is to educate and prepare you to provide security for industrial environments. Please note, you will not likely hear IoT in this presentation at all. Okay? We're going to talk about industrial things.
I do want to just add a quick point at this juncture. It's over the last, I've been doing this for well over a decade, and it's only in the last year, 2 years, that through all the things that Robert just said, this is the #1 obstacle to Industry 4.0 and IoT at this point in the game. And most manufacturers that I'm aware of now, this is a board level discussion, and they are starting to change the dynamics in terms of these industrial environments. And I mean by changing the dynamics, investment is being put in to improve the security regardless of the standard investment processes that have gone on before, which have been, sweat the assets, and the investment goes in, very, very slowly into these capital-intensive environments. The game is starting to change a little bit from that perspective. Investment's coming, and it's a board-level topic.
Okay, so some assumptions about you. And if this doesn't fit you exactly, my apologies, but this is sort of what we had in mind when we designed this presentation. That you are primarily an IT professional. Thank you for everyone having risen your hands, because that means we got that mostly right. And you may have current or soon to become responsibilities for securing operational environments. So let me ask this question. How many of you today are responsible for the security of your industrial environment? All right, some number of you. How many of you are here because you think you will soon be asked to secure the industrial environment? more. Okay. That's good, because this is actually very much what we're experiencing here, is that a lot of the discussions we're dealing with are IT professionals being told, you will start taking on this responsibility, but you're not quite there yet. This is exactly what this presentation is meant to do. It's to give you that initial understanding of what you would learn along the way and what potential challenges you may face. So for me, I'm in that position of you who are saying you're being told that you will go and do this. I used to be a few inches taller and much better looking, but I've been hit in the head often enough on this learning journey that what you see before you is the result. Hopefully you will come out of this looking much better than I do. So the agenda. We're going to talk about IT and industrial network differences, because a lot of these issues start actually at the network level itself. Fortunately, you're at Cisco Live. We assume you know a good amount about networking. Industrial protocols, some of the specific security challenges at place, some of the standards that drive it, and Cisco and Paul actually is an active participant in those standards definitions, as well as Nancy sitting over here on my left, a key participant in many industrial standards for the space of security and communications. We're going to talk about phasing security into the environment, because one of the things we also know is that most of the industrial environments you have, you don't get to go shut them down and re-architect everything as you might potentially like to do. So how do we introduce security in a fashion that doesn't cause problems itself? Because there is some fear from the people in those environments about introducing something they're not familiar with. We'll go through 4 common industrial security use cases. We'll then have what everyone wants to talk about within a security discussion, some attacks and incidents and what some lessons might be there. Talking about getting some help, some of the designs that we've done already, as well as the services that our services group provides. And then hopefully we'll have time for question and answer as well. All right, so that's our agenda today. And at this point, I'm going to hand it over to Paul, who's going to start talking about what is this OT thing?
Yes. OT, we use the term for operational technology. And depending on what vertical you might work in, that might mean in a utility, substations, distribution, generation, in manufacturing, a factory, for oil and gas, a refinery, a pipeline, an oil rig or platform, stuff like that. Operational technologies, I think in a simple way, they're trying to control and manage the real world. And in many ways, that's one of those critical things that we have to recognize. That's what drives the availability. We don't make product if we aren't, making product and controlling the real world. We don't find oil, we don't produce oil, we don't distribute electrons unless all of that stuff is going on, okay? Many of these environments, or almost all of those environments, have industrial automation and control. We use that term a lot, IACS, industrial automation control systems that are managing that physical world process. I think a very simple way to keep this stuff in mind is there's a very critical thing that's going on in these systems, a very simple but critical process. There's something sensing, something controlling, and something actuating. And that forms a control loop, okay? This control loop is what maintains the operational integrity of that environment. And maintaining that operational integrity is of utmost importance in these places. And so when you break things down, that's the process that we're going to put, we want to make sure is secure, and we're going to give priority to. All of the Industry 4.0 and other stuff is usually considered secondary. It's important too, but if you aren't maintaining that sense, control, actuate at the edge, at the physical process level, you have a problem. you have a real problem. So it's important to keep that in mind. A little bit more about that. Sensors and actuators and controllers are working in very harsh environments. There's a lot of these things, and they've typically been built with about the cheapest but most consistently running technologies out there. They've used a lot of, let's say, proprietary networks in the past. In the early 80s and 90s, Ethernet and the standard open networking technologies didn't cut it for these environments. Too expensive, too slow, just didn't cut it. They're drastically moving away from that, right? And these devices are getting smarter and smarter. Computing's getting cheaper and cheaper. So there's a lot more you can do with it. But in the end of the day, it's still that sense, control, and actuate process that has to be maintained, okay? That builds up into things like SCADA systems, manufacturing execution systems, so on and so forth. But I think that's like one of the core things to keep in mind. When we look at certain things in security, that's one of the key things we'll keep in mind.
So Paul, if I may just make a quick comment on that last slide there. Sometimes the words you use are going to be important. Say, oh, this is a SCADA system, or no, that's not a SCADA system. Sometimes the people you're working with, if they're friendly to you, they'll give a little slack, but sometimes they may be very specific. This is not SCADA. This is SCADA. So what would be a good general phrase to use? IACS, is that probably more likely piece versus ICS? It's going to depend on what it is. So just be aware that sometimes you may reference something and it may not be technically correct. If the people you work with are friendly, they'll say it's okay. Otherwise, they may jump on you. So just be aware of what those differences are.
One of the things we wanted to point out here, in many of the, especially the industrial, but as we look at those verticals that relate to IoT, what we find is the operational guys have more or less responsibility, often dependent on some of the verticals, okay? When you kind of look across this, the things in the hospital and the systems in the hospital, our understanding is the IT guys have quite a bit of play in that space. A lot of the data, is out there, is critical. The systems for the doctors and the nurses, they're actually quite involved in. But as you move and you get more and more industrial in some of these verticals, moving into the car and the transportation, the manufacturing and utilities and oil and gas, there's a drastic swing. And that swing is towards the operational guys have quite a bit more responsibility from a budgetary standpoint, from a control standpoint, organizational standpoint. And what we find is that the OT guys have quite a bit more say over some of those areas. How does this instantiate itself? What we have here is a bit of an architecture from electrical transmission, okay? What you'll see somewhat on the top is where the operations, the center and the data center, that's where the IT guys are gonna have a fair amount of play, right? When we get down into what we'll call the substation, the automation areas distributed throughout the utility grid, the operational guys are king there. The IT guys, most of the IT guys that I talk to here have almost no visibility into what's going on in these environments, okay? And then when we get back into the multi-service, let's say, aspects of things, connectivity for the people out in the field, connectivity for, voice, video systems, sometimes a lot of the safety surveillance, that's where the IT gets more involved in certain things. But there's usually they maintain a very strong segmentation. In the utility industry, NIST, or actually NERC-CIP, is part of the regulatory body in North America. they define that there needs to be a very, very hard virtual and physical segmentation of these environments that has to be maintained. You do not get certified as a utility to do what you're supposed to be doing if you can't maintain these kind of things. And it translates itself not into just technical terms, but organizational terms as well. Okay? A little bit about the history. I was elaborating a little bit on that. Depending on the verticals, they've had some different experiences in terms of how the networks and how the security has been built over time. In manufacturing, I'll say it like this, the networking and security has significantly lagged from our perspective, from an IT perspective, in terms of what they're doing. When they build production environments in this space, they usually turn to well-known vendors that supply them the industrial automation control systems, well-known system implementers that take that stuff, put it together, and deliver to them basically functioning parts of the plant. And when those guys have tended to do this, they do it in the most expedient way that they know, and they use technologies that are, strictly built for purpose. Open standard networking has, over the last 10, 15 years, been creeping into a lot of that stuff for a number of reasons. But back in I'd say through the 80s and 90s, they were primarily focused on their proprietary networking technologies and as little security as possible. They kept things highly, highly segmented air gapping. That is no longer a viable security mechanism, so they're trying to catch up quickly. Utilities have always built their systems from kind of like a high-level perspective, a whole grid. They have to manage very, very large, complex systems of generation, distribution, and utilization, and so they've had a little bit more top-down. And some of those architectures, they've been forced to use open standard networks. It's the only things that have basically supplied them, the connectivity they need. And so they've got a little bit more, in many ways, better use of some of the open technologies and security concepts built in. Transport is, I'm going to kind of say, closer to a manufacturing space. Most of the vehicles that are out there are still running CAN bus or other relevant non-open, non-Ethernet standard networks and having trouble, we've seen some of the security situations coming in. They are starting to do some basic connectivity from those vehicles and those fleets up and out, especially if they're specialized vehicles, trucks, police cars, ambulances, buses, so on and so forth. But there's still quite a bit of work to do. The industry will, over the next 5 to 10 years, drastically shift as they're moving towards autonomous control of many of these vehicles. And that autonomy, especially when you think about how it all works, requires much more communication going on and is going to shift it to what I would say is open standard networking, because that's the only thing that can support the kind of bandwidth and communication they're looking for. Oil and gas as well, reasonably similar to manufacturing, the way they build things and the technologies that they use. If I had to say anything, they're probably even further behind in some ways because the investment cycles there are so much longer. You build an oil rig for 20, 30, 40, 50 years, right? You build a refinery to run for those kind of time frames. A plant will turn itself over usually within 5 to 10 years, but some of these are just a little bit slower. Really quickly, just to go through, give you a little bit of what are you connecting here in these spaces? You have in the utility space, you have, they basically call everything an intelligent electronic device, but this is something that's helping process the flow of electrons through their substations, through their grid and those are some of the key things that they're trying to control. They have remote terminal units, which are in many ways the controller in that sense, control and actuate loop. IEDs are the sense and actuate kind of things, and RTUs are in many ways that PLC from the manufacturing space, the key control. When I talk about controllers and RTUs, a good way to think about these things are they're very simplistic compute devices built with real-time operating systems, scrunched down to work on as little CPU, as little memory, as little store as possible. But they were designed to consistently run, very deterministically run with simple programs, okay? You tend to have some sort of human-machine interface. Most of those human-machine interfaces are basically some sort of screen. Most of those HMIs are some sort of Windows application. And most of those Windows applications have not been upgraded or touched since they were deployed. What is the chance that at most manufacturing environments and many of these other industrial environments, the chances are that you're going to find something Windows 2000, Windows 95, Windows something is reasonably high. I know for facts that many drugs that are coming out in the marketplace are being managed with HMIs and systems from Windows 95 or older, okay? So just some things to keep in mind. There's some significant challenges there. They tend to have supervisory workstations where they're trying to control the factory, trying to control the grid, trying to control the refinery. So those are important systems to keep in mind. Historians, these guys love to collect data and have some sort of understanding how things are running over longer periods of time. And a lot of these devices then are kind of put together to form robots, to form CNC machines, to form other kind of larger assets you'll find in many of these environments, a compressor or some other kind of things. So that's roughly the kind of things you'll find out there. And what I wanted to highlight with some of those things is that the maintenance windows on these tend to be very, very, very long, okay? Monthly is probably, you're lucky if you get some of the high-level applications and you get security updates on a monthly basis. But quarterly and yearly is probably, in like a manufacturing, yearly is something you might be able to expect to get some changes in. And then many of these environments, I know companies that will proudly tout they have systems that run at 9 nines, 8 nines of operations. That means over decades, less than seconds of downtime. And so in some of those environments, you have to talk about updating things while maintaining control and operations, and that can be actually quite challenging to do. So those are some of the things to keep in mind as you go into these environments.
Right, so every network's got its challenge. I mean, the fact that you're here learning more about networking is one part of that. On the IT side, your world's pretty dynamic. There's a lot of things that are actually changing. You've got, I will make the argument, I probably have more applications on my PC than there is on an entire factory floor, right? It's just a finite number of things that you need to have in place there. And interoperability, we assume automatically, of course, everything's going to talk to each other because we're all using standards and the exact same phrases and such. And there's a lot of people like yourself who know basically how to run a network. To some extent, there's networks at home, okay? So a lot of knowledge, a lot of things in advance. Not quite like an OT network because your IT network would probably never be something you'd put on a piece of metal and be able to reference, for some long period of time. But for a little bit more on the OT perspective of what that network looks like, Paul will go into that.
The OT networks are significantly different in many ways. One, they're very fixed. The number of devices connecting to that doesn't change over months, years, decades. They have very limited applications. I've worked with some of the large turbine builders in this world, and believe it or not, a large turbine can have 7, 8 highly segmented networks on it. Often to maintain the rotary control, there's 3 separate networks of sensing, actuating, and control going on. 3 separate controllers that are getting information from all 3 of those networks. So a 4th network just for the controllers to talk to each other. There's some sort of system maintaining overall control of the turbine itself, so a 5th network. And then if you have some sort of IT or you're trying to get some sort of SCADA and data out, you may have a 6th or a 7th network for those kind of things. And when I mean separate network, that means separate wiring, separate switches if they're using any sort of switching concepts, that kind of stuff. So highly, highly segmented networks. How do you get to these networks? You don't. There are ways if you're going through protocols to bore down and get information from these things, but in essence, in many of the ways that they build these networks, the PLCs or the HMIs that are using are dual, tripled home and talking into these networks. And so when you go up to our solutions, we'll talk a bit about that later. One of the things that we are trying to do, in terms of Cisco is, we think you can start interconnecting those. We've got a lot of work on quality of service to maintain those properties, but we're trying to move them into a little bit more integrated networks so that you have from a security perspective, you have some visibility of what's out there and what's going on. That's, I think, one of the key things that we're trying to do, and we'll relate that in terms of some of the solutions. But
actually, go ahead and click it. We'll let you drive here a little bit. Your IT networks. You've got some pretty smart endpoints. You guys have got more compute power in some of your hands right now than a whole lot of industrial systems have had for some number of years. When you send a message or you get data, you are going potentially to the other side of the earth and back. If you're sitting next to a person and you decide to send them an email, it leaves there, goes way off to whatever comes back and goes to the person who's sitting 6 inches away. All right? That's the way our world works. So we basically have some hierarchical networks. Data is going far. File and print shares, again, you go to some central spot and then you get the data back and so forth. Most of your devices may not necessarily be really highly related to the one that's right next to it. Okay, so that's just the way that our IT networks go. We have very short conversations, a lot of different connections, and our TCP sessions are pretty darn short. And our, again, assumption is, and what have we been working on for years, let's assume everything can talk to anything else. Select star dot star should work on every database I have, right? In what cases should I have to do something wildly different? But that's what we've been working on, interoperability, and we've basically achieved that to a large extent. Unfortunately, Paul?
What I wanted to say, just to kind of finalize that, in that IT world, as Robert was kind of suggesting, the devices are talking to something far away. They're never talking to something, right next to them. Even if I have a print file, my computer sends the print file to some sort of centralized print server, and then it gets shipped back down to that printer in these days. The OT side, if you go back, I was talking about the sense, control, actuate loop, right? These devices are all talking to each other. 95% of the communication you find in these environments is devices talking locally to each other. They talk to each other for very long periods of time. That sense, control, actuate happens measured in micro or millisecond kind of control loops, and they try to keep that conversation going on for as long as possible. Months, years are not atypical to see a controller talking to its sensors and actuators, okay? They don't have nearly as many connections. A controller will manage, tens to maybe 100 or, somewhere in that kind of range of devices. and have basically one conversation with every sensor and actuator that it's working with. Most of those conversations are not TCP-based, they are UDP-based. Right when they start up, they do use a lot of TCP and heavier communication, but once they're in an operational state, those sensors are sending basic information on a very consistent basis. There's no need to build up and destroy TCP communications. They just fire off the UDP, and the same for the controller to the actuator. Just consistently firing off new commands, new controls, and there's no need to build up those UDP sessions. And so those are the kind of things to keep in mind. When you come into these places, you might find that they use extensively things like multicast traffic, right? We experienced some of that in some factories. They put in our switches or firewalls, and all of this traffic, they basically say it shouldn't be routed. There's a field in the IP header, just basically don't route this. And we used to put routers in and say, hey, by the way, if you ever drop a multicast packet, send a message to the CPU and start counting that. And when they took those configurations and put it in these environments, and there's tens of thousands of multicast packets that are being dropped every second, we found configurations actually got quite challenged by it.
Yeah, so let me just make one little comment here.
Sure.
Some of the things that you will find in these operational environments would actually be flagged by common security tools as suspect. This is an example of how the tools that we have to offer that you might be using already as part of your security portfolio will still work. You just need to understand the proper way to use them and what to look for and ignore in these cases. Okay? Some of our own tools will flag a very long-lived TCP connection as suspect. It's just sort of a default operation because they came from that IT environment. You just need to basically make those tweaks and understand. This is why we're really putting so much emphasis on the network differences here, not just because we're Cisco, and this is a Cisco networking event to a large extent, but because the security practices and some of the security tools that we have are highly influenced by the network environment in which they're going to operate. So hence all of this reference on how are these networks that much different. Go ahead, please.
Just also to start getting into how these networks are deployed, some of the differences. They don't use standard IT, kind of like redundant star, ether channel type of connectivity from switches to aggregation switches to core switches. They have different topologies. They're all about availability. They use a lot of rings because that's actually an intelligent way to get reasonable resiliency out of your network. The devices themselves often have 2 ports and form part of that network itself to keep in mind. So what you'll find, what we're trying to depict here is you're going to see these devices connected in all sorts of interesting ways. One of the things we would like to see, I think what we've got depicted here is a reasonably classic design where a PLC of 1 NIC out and 1 NIC down. And in those environments, from a security perspective, that's a challenge. You don't see any of those devices. That's not a network where from the top, you're going to be able to see that there's a MAC address, IP address, or do anything about it. And that's where the ring on the right is more like what we would like to do is get a switch involved in those kind of rings where at least then you've got some sort of visibility of what's going on out there in some of those other networks. They do a lot of line topologies, just string things along. But the key is you want to have some sort of network capability to understand what's out there and then be able to apply some of the security policies to it. Okay? As Robert points out here, most of the things in these environments may not even have IP addresses. As I mentioned, there's a significant use proprietary networking technologies, and that ranges from absolutely not Ethernet. Some things like ControlNet, DeviceNet, Profibus are not based on Ethernet. They're based on some form of serial technologies and some other kind of concepts. And so there is no MAC address, there's no IP address on a lot of those things. Even today, almost 50% of systems that are put out there in these industrial IoT spaces are still using some form of field bus technology, okay? And even I can point out a number of cases of networks that are using Ethernet, but they don't have an IP address in them. And so I think like the key point there is those networks, they're gonna be out there. They are gonna be hard to connect. You're not gonna drop Cisco networking technology into them for a number of reasons. One, we tend to be more sophisticated. And two, we don't play by some of those proprietary rules. It would be challenging. So you need to recognize that they're out there. With our solutions and stuff, we're trying to move the industry into more open standard networks to drive the whole IoT story and the connectivity story and a security story. But just a key point to keep in
Paul,
mind.
just maybe go back a little bit. So if you have friendly people, this won't happen to you, but I've seen it happen in some conflicted environments. You'll be invited into this space and told, hey, you can help us because you're the network expert. Let's go re-IP some equipment. And they hand you a screwdriver. And they point you in the direction and say, go reset the IP addresses. You will use the screwdriver to set some IP addresses on some of this equipment. You will flip dip switches to set the IP addresses on some of this equipment. They're not joking with you because that's the way it works. So again, just to give the example of how things are a little bit different, you will actually have to physically manipulate equipment to set an IP address in some cases. And those things are still being sold today.
And even if you don't have to do that, 99% of the time in those cases, those devices get set with an IP address through some sort of configuration tool initially, and that IP address never changes. You shut it down, you turn it off and turn it back on. It stores that IP address, and that's the one it continues to use until somebody comes in specifically and reconfigures that IP address. So some things to keep in mind. Moving along too, one thing I want to keep in mind here is time. Time is significantly different too in many of these spaces. As I was saying, they're trying to control the real world, so time has to be is often much shorter and much more precise in these environments. NTP doesn't really cut it. It works for IT applications. Its resolution is roughly measured in seconds, maybe milliseconds if you're good. But for many of these environments, time is critical and is done much more precisely. I will say time is broken up and considered differently. Many of these applications may not have a sense of time, like what time is it on my watch, wall time, calendar time. They will be running on a frequency, and that frequency is very, very deterministic and well measured, but not necessarily on a clock. We are, these industries are trying to move to using something called precision time protocol, IEEE 1588. It's a wonderful technology, how to distribute time in a system and maintain a very precise synchronization across these clocks, actually very, very scalable kind of time. But PTP is basically where the devices maintain clocks that are synchronized to less than 100 nanoseconds of drift, and that's pretty darn good. There are systems that get better than that, but for most of the industrial applications you guys would ever face, precision time protocol is by far good enough for those applications and something considered. And it's really important in a utility. If a substation goes down, right, things happen really darn quick. And for them to figure out what really happened, they need to know these events with when they occurred and which order they occurred, schedule of events, and it's PTP that allows them to do that. In an NTP world, if you tell these 10 things all happened in the same second, but I can't tell you which order they happened, they're like, hands up, I can't really tell what went wrong. They need the schedule of events, they need the precise time to do that. And so that becomes actually another security consideration, because if you start screwing around with time in that place, in those environments, some really weird things can happen. So.
All right, so yeah, just a few notes on time. You folks all here, and perhaps some of you are aware that some of your clocks were running 6 minutes slow for a while? Yes? No? There was a conflict going on in the Balkans between somebody paying for electricity and someone disagreed, and there was a little fluctuation in the European grid, and the result of that was the cycles were a little bit off, and a whole set of people's clocks were off by 6 minutes for several months. This is some of the relationships that we see between potential conflicts and the actual industrial environments. And speaking of time, we've got about 100 slides to go through in 1 hour and 15 minutes, so we're going to speed it up a little bit. About 2 years ago, I surveyed 620 people, and we asked the question, who's responsible for operational technology security in your organization? And it was split pretty evenly between, okay, it's the OT teams, the operation teams, it's the IT folks, and then there was an equal number of, we're still trying to figure it out. So let me ask, how many of you are in a we're still trying to figure it out situation? All right, a few of you, and then the heads shake. Okay, that's good. That's realistic. We're observing a shift, and the shift seems to be driven by the incidents that took place 2 years ago, in which the IT group is being asked to do more for a lot of different reasons, and I'll go into some of those reasons. But let me just make the advocation, because I'm being the IT guy, I actually think this is necessary, and we'll describe as to why that this is necessary. But part of this is, again, I think I told you my wife's a chemical engineer. Last week, because I have a child about to go into college, we were looking at the curricula, and he was interested in becoming an electrical engineer. And I looked at the curricula for electrical engineering and looked at chemical engineering as well. The required coursework focused on computing systems was 2 hours. And so in the United States, we largely measure the amount of work you do is how many hours a week do you spend over the course of, say, 4-year period. So 2-hour coursework, okay? The coursework for world literature was 4 hours. Okay, so my wife, chemical engineer, got a degree with honors from a major school in the chemical engineering space, had twice as much education on world literature than she did on computing systems. All right? We'll talk about why that's potentially problematic. So, what's this vision of the world here? If you've been listening to prognosticators, Industry 4.0, of course in the US we'd say 4.0. 4.0, we're going to connect everything from the cloud all the way to the lowest element that we're going to find in this factory environment. As a result, we will see massive gains in productivity, we'll become much more agile, and wonderful things will happen, and gold will rain from the heavens. The big question is, if we're connecting from this lowest element down on the factory floor out to the cloud, there are multiple organizational boundaries at play here, okay? The first one is basically between the factory. Everything to the right is the factory, potentially physically separated from the rest of the enterprise. That's what the enterprise is, just like the left side of that green line. And the left side over there is the cloud, the world, otherwise known as other people's servers, that we're all gonna connect. The purple, that's the factory. For some folks, totally under the control of the people who have more world literature experience than they do with compute. There is blue, the IT technology stack in the enterprise, and that's going to go into at varying depths into the factory itself. or the IT group may have varying degrees of responsibilities going into the factory. It all depends. And then, as we said before, the cloud, known as other people's servers. Not under your control, not reporting to you. Go ahead, please.
I did want to make one point. As he was suggesting earlier, we're seeing some shifts in terms of responsibilities. And the IT guys are starting to ask questions about, hey, this is the critical stuff I need to connect to it. This is the stuff I need to secure. So they are being asked to push down into those environments. And just one thing I want to point out to this room. You know, we've been doing this 10 years and we're working really hard, but we're still, you can find this in terms of public or, statistics on market share. We're still roughly in the 20-25% of the current stuff being sold market share at Cisco. A lot of the stuff down there is either proprietary, could often be dumb unmanaged switches and network infrastructure, and there's a lot of other providers of network infrastructure. And we're trying to do our best to maintain open standards and work with so that we can, apply security and other policies, concepts, with some sort of ability to integrate with all of that. But just to kind of point out, as you get into that space, going off to the right here, you're gonna be a little bit in the wild, wild west in terms of networking, what you might be finding out there.
All right, so just to repeat that per the slides here, we talked about the different technology stacks. For the most part, to some extent, the traditional OT technology is down at this level. There is an absolute overlap in terms of IT technology gone, right? We are starting to connect things with TCP/IP, but as we noted before, a lot of these applications, the applications which control the equipment are Windows-based. All right, so full stop, we'll just stop there. It's Windows applications which control the factories. WinCC, the Win in WinCC is not an accident. That's Windows. Right? OPC, which you may have heard of as a control application, the first O was OLE, object linking and embedding. You'll recognize it as a DCOM-based technology. This is the reason why an incidental infection caused $8.5 billion of damage in industrial environments worldwide. Everything at the factory is largely controlled by Windows applications. Now we ask the question, who's in the best position to understand the management and security of Windows platforms? It's not my wife. Okay? She's not a Microsoft SQL Server database administrator. Yet, the information necessary for her to see success of the management system, of the manufacturing system she was designing, is stored in Microsoft SQL Server. All right. There is a gap or a misalignment of skills associated with some of the equipment, or I should say the systems that are at play. And that was a big part of this. So again, security is about process. Challenges to process might be that you've got misalignment of skills to actual systems in play, or that you've got divergent attitudes with regards to the role of security in these environments. And let's talk exactly on an example such as that. Here in this continent, there was an unfortunate incident over in the Ukraine. This is the first specific attack in the utility. If you have not seen this, I really would love you to go to Wired magazine. And actually, this was a recording. So let's just talk about all the little different conflicts and sort of things that were happening here. First off, there's two people that are talking in the recording. Well, actually, so what's happening? The attack is taking place. The people who operate the systems have been locked out. They can literally see what's happening. The mouse is moving, but they can do nothing about it. All right? You've got this older gentleman who understands the systems, and he's giving this commentary, and of course, it's this deep, gruff voice, and he's speaking Ukrainian, which I don't, so I don't understand what he's saying. But then you have the younger person who has the iPhone. Of course, it's the young guy with the iPhone who's actually filming the thing. And he's getting, and he's saying, oh my gosh, what's going on, what's going on? And he goes, we should tell the IT guys about this. And of course, then the old guy says, well, what if it's the IT guys doing this? All right? So this is part of the conflicts that we're dealing with and the cultural clashes that we're seeing between this attitude of the person responsible for keeping the electricity working. This is his attitude towards the IT group. Now, he wasn't totally wrong. The attackers hijacked the IT team's remote management tools to execute this attack. So sure, you should trust the IT guys with regards to security, because it was their own tools that were actually used in the attack. Conflict, organizational priorities, key elements to the success of the attackers to bring down electricity for 250,000 people. So, can't emphasize enough the need for you to work with the operational people and for us to understand what we know, what we don't know, what we can add value to and what we cannot, and then understanding the processes to advance security. So, this first little section here, which we're running way behind, there are significant differences between industrial networks here. We're emphasizing availability and safety as the primary priority. Continually operating. Very rarely do you really get to make changes to modify things. Very different network patterns, physical environments, and again, understand the boundaries and what these may mean in your ability to secure this environment. All right, so moving forward, Paul's going to talk about industrial protocols quickly and some of their security challenges.
Yes. First off, we were talking a little bit earlier about what's out there in the field, and a really good company that I know, HMS, does a lot of work in this space, supplying a lot of the NICs and communication equipment into this space, and based on their own analysis, right, of what's out there in the marketplace. Ethernet still, after 10 years of being the primary source of new equipment, or at least new technologies into the space, they are not, we aren't near we're just approaching 50% of the devices in the field being actually Ethernet based. And even some of that Ethernet is, again, stuff that isn't necessarily with an IP address. It's just using an Ethernet packet. It may not even be standard switch stuff. So out there, there's still quite a bit of field bus technologies. Those are still being deployed, although Ethernet is catching up. More of the new stuff going in is Ethernet-based stuff. Just to kind of point out, too, when we talk about security, roughly said, the field bus stuff has, there's no real good sense of identification. There's no real good sense of authorization, authentication. They are doing, if they're doing monitoring, they're monitoring the actual process, not the security perspective of things out in those fields. So very, very little out there. The good side is without physical access, those things are rather hard to get to. And are often, due to the gateways and other things, hard, you can't just start talking to them. You have to bore your way through to them remotely or have physical access to those networks. On the Ethernet side, that's where you'll find some better security at least coming up and better potential there, because you can see things and actually start talking to them from a broader perspective. But that also increases the attack surface, so as to say. But even there, as we move around, I'm going to largely say Ethernet IP and Profinet are the only two major ones that are out there that are taking reasonable security steps. OPC is also going to start playing into this space and is taking reasonable security steps. But from our perspective, from Robert's perspective, there's even in those two areas where there is some sort of sense of security and impetus and initiative going on, it's still not sufficient for what we think is is going to be required. Okay, just to kind of like go through some of those things. As I was mentioning, there's very few provisions for security in those places. I just kind of like walk through it. They're basically wired together, and all of the devices are assumed to be able to talk to each other. This is one thing I just want to remind everybody. In many of those environments, doesn't matter if you send a packet to a controller and you tell it to stop. You have to send it in its language, right? But if you send it a packet and tell it to stop, it never stops to consider who's sending that to me. Why is this person sending it to me? He simply gets a message to stop and stops. And so that's where we, find ourselves sometimes. It's, when in those situations, a lot of, strange things can occur. Authentication is again very, very lacking in those environments. And then, the communication patterns are also quite different. Many of those protocols I was showing you earlier are based on broadcast. Everybody hears every message, right, in those kind of environments. They use a lot of multicast where anybody who wants to hear the message can hear the message, rather than necessarily unicast point-to-point kind of communication. And again, just to kind of like highlight where do you find them, usually when your organizational considerations, Ethernet is flowing downhill, so to say, on these things. It's very common to find it in all of the, let's say, plant level, higher level applications in the production environments. Most controllers these days are being kitted out with at least one Ethernet NIC card in them. Often a lot of other things too for communication, but at least one. Like to do control-to-control communication, that's clearly has moved over to Ethernet, but you'll still find some of those field bus technologies under some of that controller. You'll find more and more Ethernet is coming into play there. That's most of these guys will have that choice, but again, a lot of people still are deploying field bus technologies.
So actually, if you could maybe move back one. So just, if these architectures and the notion of dealing with field bus scares you, good reason. The semi-good news is chances are no one's going to allow you to touch that anyway. Okay? And if you're being asked to come in and secure these environments, that should be like the last area you should probably get directly involved in. And in some cases, you would actually be contractually prohibited from touching any of that. Because the people who built that equipment say only we can make any modifications to it as well. All right? Now, that could be good news, that could be bad news. It's going to be a combination depending on the situation. But the chances are, the more foreign it is to you, the less you're actually going to be in a good position to act on it. And that's not inherently a bad thing. All right? Everyone's got their skill sets. Everyone's got their understanding. Do what you're confident in doing. And in some cases, if it looks really foreign and if it gives you a little bit of fear every time you see it, that's good. On the other hand, you probably aren't going to have to do too much at that level anyway.
I think it's less than a handful of people at Cisco have the right to go to oil rigs out in the ocean to actually do any work. You have to take, I think, well over a week of safety training before you're typically ever allowed into some of those environments. So even just walking into a plant environment, I've been through security training and other kind of considerations. And so going into those places is not simple.
Yeah, actually, we should have added a slide here on the clothes you have to wear. You have to have change clothes. Steel-toed boots, fire retardant, coveralls, personal protection, all these types of things. I have a separate wardrobe I'm from Texas, so of course I have this stuff in place. So protocol awareness.
Just a real quick one. We did that for sales guys. One of the good things if you wanted to do is go visit a plant, but if you go visit a plant, a few things, wear steel-toed shoes. If you want to wear a jacket, you are outing yourself as somebody who doesn't belong there. That's some of the key things. Wear plain clothes that can get dirty, stuff like that. So interesting
All right.
things. Yep.
So protocol awareness. Protocols are unique. They have interesting conditions about them. We have been inspecting industrial protocols through our firepower product for some number of years. And it's not just a simple pattern matching. So how many of you actually work with Snort or firepower? Any of you guys, some of you? All right, a handful of you, very good. You guys are the security aces. My congratulations on that. If you're not aware, we actually have specific decoders. These are parsers designed to actually understand particular protocols. There's about 33 of them. Most of them are IT related, but there are a handful of which are dedicated to parsing apart the components of an industrial protocol and then allowing you to build out rules to match on the conditions you're interested in. This is just a few of those things that we go there. You could either do things yourself on a pure brute force regular expression fashion. If you don't know what regular expressions are, that's perfectly fine. You're probably not among the group who raised their hands. If you do, however, recognize that there are a lot of people out there who are building out rules that will run on Cisco products, and they're not Cisco employees. Nations, governments do the same thing, all right? German government publishes rules written in Snort that'll run on these products and such. So the good news is that there are open source tools and tools, obviously, from Cisco, which explicitly understand the structure of these particular protocols. Quick summary on the protocols security here.
Keep in mind the protocols were born from these proprietary systems. Little security considerations put in mind. Often some very strange networking concepts and ideas put in mind. So keep that in mind as we move forward. And then I think a real basic way to approach this from a security perspective, and it's something we're trying to reflect in our solutions, get visibility first. Don't walk in thinking I'm going to do segmentation right away. Don't think I'm going to actually look at these protocols and start doing something about it. First steps first. Get visibility what's out there. Start to understand what are the devices out there, what are they running, where are my critical gaps, where's a Windows 95 box that, ooh man, I got to really be careful what's talking to that thing, okay? So get visibility. We're starting to put more and more net flow into other stuff. Understand who's talking to who before you decide to say, I don't think those two should be talking to each other. One thing to, as we were kind of referring, availability and safeties first, the easiest way to get yourself kicked out of a production environment is to turn it off or cause an outage. So take slow steps, get visibility, understand what's talking to what, who's talking to who, what's on the network before moving into things like I'm going to do segmentation, I'm going to do deep packet inspection and take any action in these spaces. So.
Yeah, so we have a whole section on visibility coming up. Hopefully we'll get to it. So let's go ahead and move to standards. And Paul's going to start talking about standards because he's an active participant in some of the standards work here.
Yep.
But I'm going to kick it off on ISA 99. ISA 99 is probably the progenitor, the initial industrial standards work there. You are looking at a literal photo I took of the standard itself. What I want you to be really observant of here is kind of the tone towards security. Security objectives are defined in a negative sense. Security will not cause problems, okay?
It's like a doctor.
The very standard itself says security is a risk. I did not do the underlining. The underlining of this opening statement came from the authors of the document. This is what you are facing as a security person. All right? I'll just leave it at that, and then we'll go forward here. But just be aware, if you've got working with anyone who's been focused on standards, this is the first statement that many of these industrial people ever really read about the security of systems. And it's not a positive one.
Yeah. They did go on to do some very good work in terms of putting together what I think, and I think most of the industry recognizes as a standard model or framework for cybersecurity in an industrial setting. ISA 99 is a US-based standards organization, so the rest of the world doesn't necessarily love the fact that it's just a US-based. There's something called IEC, which is a huge political nightmare, but it is global and did get convinced to adopt most of the work ISA 99 did, but you will find the standard now more commonly referred to as IEC 62443. And just really briefly, it's good because it starts with some general considerations and definitions and stuff. It does some good process level, establish policies and procedures and gives companies in the industrial space a good perspective on that. It has its system requirements. We were talking about industrial automation control systems. Well, from a systems perspective, they kind of define what some of the features and functions should be there. And lastly, they are also getting down to component level security standards around development life cycle. So anybody from Cisco, good news. Our guys helped write those things, so CSDL is highly reflected in some of that. And they're also defining, from a technical perspective, what should a device be able to maintain. And they are just starting to certify companies for their processes and for their devices, okay? There's also something called Industry 4.0 and the reference architecture for manufacturing model there. This is security is kind of reflected here, but this is more for manufacturers to think about a bigger IoT-like model where all of their products have go through research and engineering and development, go through manufacturing, go through operational life phases. If you wanted to build a digital twin model, this is a good thing to look at and think about and consider. It's for us, we play some roles in this from a Cisco networking and security standpoint. The key here, and they recognize this, ubiquitous connectivity is an absolute requirement for this model to work. So some of our earlier discussions about we're trying to connect all of this stuff up, well, for all of these guys, they recognize this kind of digital twin, this kind of Industry 4.0 model, it requires, as it says in the Internet of Things, internet and connectivity. As well, in much of this documentation, when you get into the systems, they talk about many of these environments are designed into zones, and that's a critical kind of concept. For us, zones usually translate into things like VLANs and stuff like that, layer 2 environments. For them, I think that's a good association, but for them, zone is basically an area where some sort of functional process occurs, usually where a controller or a set of controllers is managing a physical process, okay? And so we ask them to kind of like build things out in that. In terms of those kind of concepts, and then interconnect those zones to other zones and into the network. And so what you end up finding here are some, these are the way cars are built, this is the way factories are built. You have these different functional zones, often interconnected, sometimes just to themselves, that creates a larger network, okay? This is an example of a factory and some of the, actually a subset of a factory. It's basically the painting section of a factory, but just kind of like highlights, there's different zones, and as a car goes through these processes, it flows through these, different things, but to note here, there's often very similar zones to other zones. They do the same function. I mean, they may do it slightly different depending on what phase of the painting they're doing, but an oven is an oven is an oven. So things to keep in mind.
Yeah, so just a quick comment on this. So from a security perspective, I've got these 16 different stations here. These may be produced by 7 different vendors, okay? With varying degrees of you can do this and you can't not do that. All of these ovens may be absolutely identical with the exact same IP address range, okay? This is one of those challenges that you're dealing with. There may be varying degrees of, yes, I should be able to access this when I need to or want to types of things. But the point is, from a security perspective and a networking perspective, it can represent some significant issues there, particularly organizational question here. Who owns the relationship with the people who built the ovens and so forth, and what are our obligations thereof? So, go ahead.
Yeah. And I'll just kind of also point out from a, keep it in mind from a security standpoint. You may be working with the factory that owns this, the customer, right? And he is dealing with a number of vendors that make this, and then one SI that puts all this stuff together. And they may face you with the challenge like, I'm a big manufacturer, I like Cisco, but in reality, I don't buy any of your industrial switches. Your industrial switches are bought by the guys that build those zones. Your industrial infrastructure is bought by the guys that put together the system implementers that put together the whole section of the plant there. And so if you want to do anything from a networking and or security perspective, you've got to be working with those guys too. And so that's an important consideration as we get into these spaces. There's a whole ecosystem that we need to work in. We talked about zones in this standardization, the cybersecurity. The other thing that they talk about is you define your zone and then you define conduits. So the idea of the conduits is these zones, what needs to be communicating between these different zones and different parts of the plant. So that's a really good place to start applying and in our solutions when we do get into segmentations and stuff, that these conduits are the first things that we're going to start deploying. And then we'll move into the zones themselves and start managing some of the security within the zones. I do a lot of work with the manufacturing companies and trying to apply security in this space. Our first question is, let's just get to manage the conduits before we actually start looking at what we're going to do within the zones themselves. Okay? And using things like ACLs, dynamic ACLs, or secure group ACLs, VLANs, and stuff like that are the key considerations. Okay?
All right. Some firewall rules and some things to consider. So this United States National Institute Standards Technology list of standard firewall rule practices. Now they have some specific statements referencing SCADA systems here. It's not really just for SCADA systems. You can just say industrial systems in general. A lot of good standard things. I do have a potential concern with the top one, which is the base rule set should be deny all, permit none. The connectivity and the ability to understand the operational state of the equipment is critical. Thus, one of the concerns, and a legitimate concern, that the industrial people have is we are introducing a piece of equipment or a practice here whose practice is to, by default, stop the communication. All right. When we designed the industrial firewall, the ISA 3000, one of the first things we learned is that we gave it to somebody to test. They simply took it as it was, wired it up, and was shocked that the traffic did not go through. Because by default, the box is designed to stop traffic. As such, this particular practice caused us to change the design of that product, and we basically removed that default line. Now, you could obviously put it in there, but as all of you know who manage firewalls, deny all is something that you put in there. We actually took that out. This is an example of how you can get security applied into an environment, appropriate behaviors for the people that you're dealing with there as well, okay? So while yes, deny all is absolutely a standard firewall thing that you should have there, be very cautious about what it is that you're doing with that in respect, okay? So we've got a whole lot of slides to do now in 22 minutes. So we're going to just start moving. So some first principles here, focused on standards, zones and segmentations. These are the phrases that are used in the standards bodies. It basically means segmentation and communication across segmented parts of your network. Let's talk a little bit about phasing things in. This is how do we start the process and journey of securing these environments without causing harm to the environment itself, okay? Basically, like this example here, we've got the traffic's got to keep going while we're doing this major construction. That's pretty much kind of the way it looks. So the concept of phasing security in is pretty common for those of you who have been security practitioners for some time. The continuous diagnostics model goes through explicit statements of phases 1, 2, and 3. You apply these according to the status of the environment and systems you're trying to secure, okay? All right, and there's going to be hierarchies within here. Asset control, you need to understand the endpoints to a certain extent. If you have a choice between discovering the firmware version of a sensor in somebody else's machine or applying a firewall to the top of your plant, put the firewall in first. We can worry about the minutia associated with some of the equipment that you're not likely to be able to deal with later anyway, okay? So it is always a pragmatic approach as you go into these things. The big point largely is this needs to be an evolutionary process and not a revolutionary one. This actually should have been a build. I'm a little disappointed it's not working out here, but let's go through. Oh, here we go, good. The first thing that I normally like to emphasize is let's look at the network design. We've been talking to you extensively about the network because if the network design is out of control, you can't defend it. Let me just repeat that. Network designs at times are indefensible and potentially problematic in and of themselves. Thus, I almost always want to understand, do we have a nice hierarchical, resilient network design? Because we may want to address that first. And as we've mentioned multiple times, we want to modernize that network because a modern network environment provides information for you as well as means to enforce security policy. So I always like to look at the network itself. The second phase is getting visibility and being able to control activity over that network. Understanding some commands that are potentially problematic. As Paul says, you send a stop command over the network environment, everyone who hears it will stop. They don't care who you are, okay? Simultaneously, there are in fact explicit threats that can cause harm to the environment itself. There are vulnerabilities, people can take advantage of those vulnerabilities and address it. But other times it's simply, if you try to make more than 200 connections over a minute's time to a piece of equipment, it might fall over. So just some simple network health is sometimes at play here. And thirdly, we talked about the need to connect things, to capture information from one place and provide it to another. These cross organizational boundaries. So we need to be able to coordinate between the IT side and the operational side. If I want to allow the ABB tech to access the ABB pump or robot on the factory floor, that should come through my IT side and then come over to the operational side. I need to coordinate access policies across those groups and be able to understand that. Your maturity within these environments, the amount of cooperation that you get, or your organizational empowerment to achieve these things will determine your likely success. In all cases, you must work with your operational coworkers to make this happen.
I just want to also say, as you go through this process, test, be cautious about what you do. Probably the number one story that I hear in many of these environments is you get to phase 2 and the IT guy wants to understand what's out there. He takes his standard IT tools, which is going to do an IP scan on everything in the network and try to figure out what it is by hitting every port that could potentially, that device could be talking on. And you know what that thing does? He gets out there, finds an IP address, and sends 1,000 messages to figure out which ports this thing talks to. You know what some of these devices do when they get hit with 1,000 messages? They go, oh, I don't know what to do anymore, stop. And then that IT guy, he never sees that plant ever again. He's gone. Something stopped and he's gone. So as you're going through these phases, do it cautiously, do it as often as possible in the languages and the tools that are available to you. These devices were intended to talk, with a lot of those protocols. When we do our work there, our work has been focused on using those protocols and talking to these devices lightly and getting some information out of that, either very passively, just sending their packets up and understanding that, or talking to them very lightly in the languages that they understand. So, and then the last thing, very cautiously start taking actions in those third phases, because the last thing you want to do is impact availability.
All right, so we've got a long way to go. Basically, it's going to take time. Worked with a major electronics manufacturer in Japan. Their plan is 13 years. It's a 13-year process. They're going to do a proof of concept for 3 years. They're going to move to about 7 plants over geographical places, different continents, of different types of plants, and then they will roll it out to the next 350 plants. But it's 13 years. You cannot be in a hurry to make this happen because things have to keep operating. So you'll have to think in some longer-term time frames to make it happen. Unlike our presentation, which terminates in 35 minutes, so we're going to keep going. So 4 particular common use cases here: secure connectivity and segmentation. We discussed that to some extent. Threat control, a safe work environment, what that might mean from a security perspective, and then secure remote access. Segmentation. How do you learn what should be segmented? You will need to have a lot of communication with the operations team. Okay, what is the scope of the project? Are we starting from this lowest level sensor all the way out to the cloud? Because that will drive a lot of segmentation discussions. Are we going to keep it highly localized within the plant, maybe just on the plant floor or across from the plant to a warehouse site? These are all questions that you need to determine that will drive some of your segmentation policies there. Talk to the operators, and in some case, you will have to follow wires. You will put your hand on the wire and you will follow it. By the way, the wires will look very different down there. Some of them will be very, very thick. You'll think it's a power supply line, but in fact, no, that's a communication cable. Okay? If you can find documentation, I consider you very lucky. A lot of it will be lacking. Not that the IT department has got a perfectly documented network and set of systems there, so we will cast stones very gently, but it may be a little bit worse there because the people who design some part of the subnet don't work for your company, and they weren't obligated to deliver those pieces. Listen to the network. You may want to put some taps in and find out who's talking to who. If you have modern network equipment, we can capture flow data. Unfortunately, chances are the majority of your network equipment doesn't provide that capability. One of the reasons why we like to advocate to update the network environment. Updating the network environment allows us to learn more and to enforce more. There are tools out there that can help with that. And they can plug into some of our own products here as well, right? And in some cases, you can query the network somewhat safely. We have tools that'll do that, such as Cisco Industrial Network Director. And you can put rules into firepower. it will discover devices on the network as well. In this case, here's the rule to discover a Siemens Symantec S7 piece. Again, listen and review. You build out these maps, go to the IT people and say, OT operations folks, and say, is this what you think is going on? There's rarely a single version of truth, very much like on the IT side. In this case, it may be a little more exaggerated. Fortunately, not nearly as many systems involved here as well. How should we think about segmentation? Let me put the point this way. If you wish to control access or behavior for any particular element, you need a control point by which to exert that control. Thus, you must segment it. Okay? If I want to control access just to that robot, I need to be able to have control of that port on that switch. It has to be a reasonably modern switch and port that will allow me to have that control. The cell in which that functional area that robot may exist is a very logical place, and really that standard was focused at that level. Effectively, that cell machine level is where we want to emphasize that. And there's a very good reason to have that control there, and there's going to be some incident examples we will hopefully get to later on today. The next gold box, the factory floor itself. The next gold box, the entire factory. Level upon level of segmentation to build out the ability to control what's happening and protect the components thereof. Now, one of the things the standards don't really emphasize is application segmentation. So specifically, this particular cell is running on Profinet. Maybe it comes from Siemens. There is an application up here, WinCC, from Siemens. That should control that source of equipment, okay? But this type of concept of application segmentation is missing from the standards. So you need to understand the control applications running on Windows boxes up here and the equipment below. Why that's particularly important is because every incident for the past 4 years that impacted an industrial system basically came from that next level of applications. That is the source for the attack on the Schneider security information system. That's basically what got shut down and caused all the factories to go idle. Understand that stack and segment appropriately. Now, that will then extend out to your enterprise because we want to get data from the equipment all the way out to your ERP and MES system. So I need to be able to convey and relate and control that communication path as well. Again, another layer of application segmentation. And of course, inevitably, you've got Siemens. They would like you to send this stuff all the way up to their MindSphere cloud system. GE would like you to send things to Predix and so forth and so on. So your application stack and your application segmentation will have to extend at varying levels all the way out to the cloud, if you so choose to take it there. Note how many different organizations' boundaries am I actually crossing here? We will have to coordinate. Coordinate all the way out to somebody else's server. All right, and of course we got multiple of these. I've got the Siemens cloud, I've got the GE cloud, and so forth and so on. So wash and repeat. I think we've mentioned this before. There's a lot of challenges to some of the network designs that you're dealing with. Sometimes the people who built this equipment would like to make connectivity easier for them, and they think a 3G, 4G modem built into their machine is a great way to do that, okay? In security, we call this a backdoor. By bypassing all security, life becomes easier for them. It's a nightmare for you as a security person. Find these, treat them with extreme prejudice.
I just want to go back to that real quick and just add to this point. Even Cisco has to get into this game. there are a huge range of people and companies out there that in their OT space, they don't have an intelligent network. They do not have security in any way, shape, or form in these environments. And there are operational people that are accepting the story, drop in a cellular modem, okay? I've got robots and they're not working for me. I gotta keep this plant up and running. I do not have a consistent network in my plant. I do not have IT help in any way, shape, or form in those environments. And they are dropping in cellular modems to get the plant up and running. So it's just, we're trying to work with that scenario. I'm trying to kind of like say, in an intelligent plant scenario, you should not be dropping L3 or these cellular modems in. You have a security structure, use the security structure that's there. But the reality of the situation is, in many environments, you're going to have mobile assets or distributed assets from somebody's perspective, and they're going to want to have access to them. If you're lucky enough to be in that plant, yes, you should be saying, I don't like the idea of back doors in my place, but realize that these guys are making that decision for key operational reasons in many cases. And that gets us to the point, modernize those industrial networks. Cisco at this point does have, I think arguably speaking, the broadest, the best set of industrial networking and security equipment, from wired to wireless, to LoRa, to embedded, to the firewalls. We have the best, broadest, deepest range of equipment. I think no other player can put up this kind of portfolio out there. And because of that, we can start applying a consistent security concept and framework and model across this. And I think that's for Cisco, some of our key selling points is that we've got the connectivity covered, and we were able to apply a holistic security approach to it.
So again, modernizing the network, a key element, the base by which you're going to create your security. You can only see and control what the network's going to allow you. It's actually, to some extent, a physical limitation as to what's going to be possible there. How to go about this process and the segmentation, again, this is the base. The network design, the logical design of communications, this is the base. How to start. So start at the top of the factory. If you don't have a firewall or an IDMZ separating your operational environment from your IT, do that now. There are Fortune 500 companies, very large entities, I find that have still not done this. It shocks me. I used to assume it was automatically there. I've given up on that dream, and so now I always ask the question. Start there at that industrial factory edge, have a firewall, a pair in place. Routers and switches, next-gen firewall, that's what you're going to need to be having there. Standard network environment for branches, if you will. We need to move closer to the equipment, but we have to listen and learn. Understand what exists today with regards to communications and what's happening. You learn that through things like our industrial network director, Stealth Watch, which will provide you that flow information, assuming you have equipment to provide the flow information. It may be you will only be able to listen at the top of the factory where you have modern network pieces. As you go closer to the equipment, you may lose that visibility. Hence, one of the reasons we would like you to update your network so that we can get more visibility closer to the equipment and apply the proper policies. With our IPS tools that we have, industrial firewalls, next-gen firewalls, which understand the protocols as we discussed. You can put those in a tap and understand the explicit commands that's going on, which again will allow you opportunity to understand how will I segment. And then, of course, you're going to move on to then understand how we should build out the network with its access control policies. TrustSec, working with our identity service engine, would allow you to apply those policies. And then we can insert explicit network defenses like the IPS and application control closer to the equipment. As such, we will have a complete end-to-end protection because we have things that actually protect the cloud and segment thereof. This particular cloud application is dedicated to this portion of the plant. This one may be to the maintenance house, whatever it may be, or the warehouse, okay? End to end, right? We make those connections. We've got the industrial switch to connect the one piece of equipment, the robot, all the way out to the potential robot manufacturer, and we can make that secure end-to-end as well. We don't think anyone else is in that position. So let's just go ahead and...
Can you go back real briefly? That right-hand side, we have that up and running in our IoT world of solutions. That model of IND, ICE, Stealth Watch, getting the information and doing that visibility and then segmentation. Go up and take a look at it, get a feel for it. It's been one of our more popular demonstrations over the last year in a lot of these industrial places, but go up there and take a look at it.
Okay, so let's move to threat control. Let's see, we're about halfway through. Vulnerability exploitation and malware protection built in. Again, piece of malware not targeted by industrial systems at all took down all of the plants around the world to a large extent, okay? We've got some explicit discoveries in that area and we have protections for it. So you will need to have this level type of control at some point. Vulnerabilities in operational equipment largely are IT class vulnerabilities. Automation people do a great job with automation. They've done a lousy job on web interface securities. Not surprising. Unfortunately, a lot of these things have web interfaces. So it's not just some kind of unique operational technology type of vulnerability. The problem is when they start to apply IT types of things on this OT equipment, and they've done a very poor job of it relative to security. As such, a web vulnerability protection rule is very legitimate in a factory environment. You wouldn't think so, but unfortunately, that's the reality of the numbers. Cisco Talos, our research group, we have a dedicated industrial control systems research group. They produce all kinds of protections out here. They discover vulnerabilities. Here's a set of vulnerabilities discovered at Schneider Electric. In red, I don't know that you can read this. But you have something called the truffle hunter. Who knows what a truffle hunter rule is? Nope. That is a 0-day protection rule. What is a 0-day? 0-day is a exploit against a vulnerability which has not been yet publicly disclosed. Okay? Somebody knows about a vulnerability. The people who own the equipment have not yet acknowledged it, nor is there a patch. Very unusual that we produced a 0-day rule that was enabled by default. Pay some attention to that if you are a customer. But we do things such as vulnerabilities in things like Omron, this is just sampling, Rockwell, Siemens, Mitsubishi, FLIR, so forth and so on, as well as application controls, such as SCADA MMS conclude response. I want to know when that's going on. Other types of things here in this class here as well. I think that there's going to be some, SCADA control for connect operation, other pieces as well. So you have both just, as well as identification of activities in the operational place, as well as vulnerabilities. It's all basically produced by Talos. Why this is particularly relevant, again, you don't get to stop operations to go off and patch stuff. Thus, when a vulnerability is discovered, the patch is published, your maintenance window may be another 10 months before you can apply that patch, assuming you are allowed to apply the patch. The patch may apply to a piece of equipment in a machine you are not allowed to touch. As such, you must mitigate that risk, and one way to do that is to put inline protections into the network environment. We mentioned the older operating systems that we're dealing with. We have explicit policies which cover vulnerabilities associated with these old and end of support pieces there. This is, again, within firepower, and we can address that. Safety. You can use your segmentation, your network and security practices to improve the safety of the environment. Security, in many senses, in this industrial environment, is probably even more about the hinges on the door than it is on the lock. Okay? So, safety is absolutely everything. One of the ways that we can provide safety pieces is actually understanding changes that are unplanned or undesired to the operational state of the equipment. As an example, if someone is sending a Modbus command, and as Paul mentioned, if it receives it, it'll do it. I'm here to serve. We can actually look at the values associated with that tag. And if it happens to exceed the safety rating or operational state of the equipment, we can flag somebody. Hey, the cooling system should kick in at 50.0 Celsius, not 500.0 Celsius. It's a big difference. For those of you who like astrophysics, you remember what happened to the Hubble. Similar type of situation, okay? We can do inspection of explicit industrial protocols. Here's another example here. So we have things unique to the Rockwell operations here. These are vendor unique conditions as well as the standard ones from the, as defined by ODVA. How many of you were using IPSs, say, in the mid-2000s? Anybody? Not many? Okay, well, that was me. I was working for an IPS security company in the 2000s. The concept of introducing an intrusion prevention system in line, even in the IT spaces, made people get nervous. They will be even more nervous in the operational space. So how do we go about doing that to help minimize the pushback and the concerns? So first off, we're going to do it slowly. Again, we're introducing security to help, not cause the problem. So there's a switch. Here's a machine. That blue thing represents the machine. Note kind of the funky network thing. You're not going inside there, okay? Put this thing in tap, span, whatever you switch is going to support for you. Watch and learn. Provide the flow data up to StealthWatch to see who all it's talking to upstream, okay? Second, tune the rules that would fire potentially that you're interested in observing or maybe even taking actions on, but keep it in that span mode. That way you'll see what would have happened if we had happened to see that match, okay? Again, every step you repeat and you observe and you get inputs from the operational team. Now, thirdly, you can start to go in line, but keep it in a non-blocking mode, alert only, okay? What I want you to observe here is potential latency impacts of doing the inspection while it's in line. Now, the Firepower products have latency controls that will automatically kick in, and you can actually tune those. But this is the understanding of, do I have time-sensitive activity going across that wire that may even say, I should maybe never even put this piece there. But observe, again, and consider the latency considerations and the impact of doing inspection. And then finally, you've done this over months. You've gotten the buy-in from the operational team. Now you can go ahead and put this in there and do some good security at play there. And of course, hopefully sleep well. Remote access. Let me just say that when I have meetings with customers and we talk about security, this is the longest conversation we have because it is a big, sticky mess. All right, there's no way to get around it. The basic premise here is I've got a technician somewhere else, and they need to gain access to something over here, all right? There's a lot of considerations at play here. What's the security status of that vendor and their device? I have no idea. We'd like to have an idea. What's the quality of service necessary? Why is that relevant? If I'm manipulating a robot in close proximity to a human, I must have line of sight. That means video. Quality of service and video are tightly related. If the image has been frozen for 5 minutes and I'm still doing stuff, that's not a good combination with you manipulating that robot. And again, organizationally, how do I coordinate this access across these different organizations? And then finally, how do I even know what was done? How do I roll back potential changes? There's a lot of details behind this. And of course, at some point, the technician shows up, and now they're on my factory floor. Remember, everything's a broadcast world there, it's low flat, there's really no thing. Hey, if he sends a broadcast to what's his machine, he may hit 5 others by accident. So a lot of challenges here. Start looking at contracts. This is a very real contract. I've hopefully purged everyone's name out of it to comply with all the other good things here. Condition C, you will provide remote access to the system to enable a third party to perform its services, but not limited to VPN access. No, we don't know exactly this. The final line here, we will tell you what is required when we show up to do the installation. It's too late. You've bought the machine. They're installing it. That's when they'll let you know what the remote access conditions are, and you will have to apply. Question, for those of you who are working on factory security now, how many of you have actually seen the contractual obligations imposed on your company by the providers of equipment? One man, my congratulations. Stand up, take a bow, because you're the only person who has half a chance. I'm sorry.
3.
Oh, because you're one of the integrators. Yes, okay, very good.
It's
all right.
his fault.
Find the contracts. Potentially more importantly, if there's going to be a new contract, get your legal folks involved and get some boilerplate language to go in there. Better yet, don't wait for the contract. Put it in the RFP. Put it in the RFQ. Whatever process by which you're going to buy equipment and get it installed, get in front of this thing. Because right now, you have no idea what you're legally obligated to provide, and it may create an absolute nasty security mess. Okay. Department of Homeland Security, U.S. government, has got a very nice document telling you how to do it. Basic concept is the following: never a direct access from outside your organization to any piece of equipment in the OT environment. Full stop. Always a jump box. In the United States and North America, Canadian, and a little portion of Mexico, there is a law that says it is illegal to provide direct access to equipment involved in the electrical grid. Okay? You don't live in the US, that law won't help you, but at least you can reference it and say, that's a good idea, we should do the same. Okay? Speaking of trust, speaking of third-party people here, the biggest fine that was applied last year under that law was applied to an entity who trusted a security company. The security company screwed up. Was the security company fined? No. The people who hired the security company got fined $2.7 million. Okay? So, don't trust anybody. Don't trust us. Don't trust me. Okay? Zero trust, anywhere you can.
Key learning
Yes.
out of this.
All right. Okay, I'm an American citizen, hence all the references to the U.S. Things. This is a very good concept. It's called DFARS. This is primarily a contractual obligation in contracts. If you are delivering goods or services to the United States Department of Defense, there will be contractual obligations stating what you must do to keep things secure and access and so forth. This reference says you in turn must impose the same conditions on every subcontractor on down. Okay. My brother does real-time programming on industrial equipment. He likes to work from his local library. He is not hired by the contractor. He is in fact a hired head who works for another subcontractor. He uses a series of other people's login credentials to get to a particular asset on an automobile manufacturer plant floor. They have no idea who he is. And he's under no obligation to protect any kind of information or anything along those lines. Okay? Security flow down in contracts. As I said before, this is about process, this is about organizational sanity. You start at this stage. Can't emphasize it enough. Otherwise, you're going to be chasing the past. Take control of the future. All right, use cases, we've gone through that. Okay, attacks and incidents, what might we learn from them? This is usually what everyone gets excited about. Are you familiar with the concept of a kill chain? Those of you who've heard of the kill chain, hands up, a few of you. Yep, including the guy who knows his contracts, congratulations. Basically, the process of purposely attacking a target pretty much goes through the same steps over and over and over again, all right? We need to understand the environment. We'll do some reconnaissance. We will do some explicit targeting. We will understand which particular weapons that we will use to activate the process there. We will then deliver these things. We will exploit potential vulnerabilities either in equipment, devices, applications, or the organization. We will persist, meaning we will continue to exist in that environment, and then we will repeat until we get to the environment that we want to actually initiate something. Okay, so the kill chain, there is always a process. So let's first talk about an incident that took place to a traffic control system in Los Angeles some years back. What makes this interesting to me is they knew they were likely to get attacked. Basically, they had a labor situation internal for the folks that were actually managing the traffic systems inside Los Angeles. So they knew in advance that something bad was likely to happen. It still happened. Okay? What happened? There was a sympathetic system administrator, sympathetic to the people going on strike, who shared some credentials with them. They in turn went in and issued problematic commands. There was no hack, full stop. They issued commands, commands were accepted. Suddenly traffic lights at certain key places in Los Angeles. If you've ever been to Los Angeles or most any Western US city, you understand we really like our cars. Public transportation is so inconvenient. Cars, cars, cars. Los Angeles was basically snarled for 3 days. A little closer to you, we had this incident in Germany with regards to a smelter. I'm only going to use the publicly known information here. There was the process. There was phishing, there was malware, someone gained credentials access, commands were issued, and things were damaged. A lot of, again, the same process. It all started on the IT side, and it was only at the very end when someone issued the damaging commands did they do something unique to an industrial control system. But as we said before, if you can issue the command will be carried out. Clearly, you have to stop things before you get to that point. As we talked about before, there's ways to control that. We've got tools to recognize phishing, to recognize malware, and to control the actual commands. We are not ready to accept a shutdown command. I like to use this concept here. You need to get out of the car. I command you to get out of the car. The process of getting out of the car varies if I'm going 100 kilometers an hour or if I'm already parked. Okay? Understanding the process and the impact of the commands and how these things will change. We talked a little bit about Ukraine already. I won't go too much on that other than to say this was a beautiful attack. It was amazing. What these guys did was highly sophisticated, highly integrated across a lot of different areas. I don't advocate this just because I admire the nature of the attack, but let me just say they were attacking a lot of different things simultaneously. One of my favorite things is that they DOSed the telephone response system. People could not call in to say my power went out. There was no way to report the problems. Now, why is this particularly relevant? At least within the United States, there's legislation in our governing bodies to say we must roll back some of the advanced digitization of our electrical grid to simpler, more analog controls. This is not the direction we think things should go, but this is what the potential causes may be. It's bad things happening. All right, we're going through that. All right, we talked a little bit about these attacks. I just want to make the biggest point here. In no way was any of these people targeted. To say it was an attack is actually somewhat incorrect. Why this is particularly interesting and relevant for you is that one of these companies, Mondelez, had cyber insurance. They asked for the insurance policy to be paid on. Their insuring company, Zurich, refused. Why did they refuse? Anybody know? It was not an attack, it was self-inflicted. Good thought. Perhaps they were negligent, they didn't protect themselves. That's not why. They said it was an act of war. Somebody declared war on a confectionery maker. That was the excuse. You should pay very close attention to this legal case. Some of you are not working for a government and are not likely a direct take, but they basically said it was an incidental carryover collateral damage from a war. So in Cook County, Chicago, the United States, Mondelez versus Zurich, pay attention to this because it can absolutely impact your world. It is a very interesting scenario. VPN filter, this is something our Talos group discovered. Infected over 500,000 routers, kind of low-end routers out there. What people didn't realize is that, by the way, it was listening for Modbus. Why would it listen for Modbus? A lot of these things were associated with municipal utilities. Specifically in the Ukraine, apparently, someone tried to shut down a water purification plant through this particular attack. A cloud-based system in the US was hacked and 4 pipelines stopped operation. What are the boundaries of your system and what they need to operate? A subcontractor to an electronic data interchange system got hacked. As a result, in April, some people did not get heating gas, some transportation systems did not get the natural gas to run their buses. What are the boundaries of your systems that you need to consider when you're doing your threat modeling? And then finally, for those of you in the manufacturing space, we have another geopolitical situation. The United States and China are not getting along. We're throwing tariffs at each other left and right. Some folks in Taiwan thought that was a great opportunity for them to improve their electronics manufacturing productivity. So they went and bought some new equipment from their provider. A new electronics assembly piece came into the plant. That machine was infected. There's very little to no security at that lowest level, machine talking to machine. The infection spread across and shut them down. Why might this be relevant to you? Well, if you own an Apple iPhone, there was a little bit of a glitch in the Apple iPhone supply chain. That's when people started to care. Oh, now I've got fewer iPhones. Okay? So this is the thoughts. Again, you're thinking security is process. Security is analysis, risk, figuring out what has to be done. You have things coming in from the outside world. There was a gentleman I was speaking to, make paper, yes? Louisiana Pacific, ex-employee, dials in, he got fired, had the old credentials, dials in, causes a lot of damage to equipment there. There's a lot of different risk vectors, and they expand in the industrial space in manners you may not be used to, okay? So with that, I'm just going to, yeah, we're over.
If I could just say, in the getting help, come out to the IoT section in the World of Solutions. All of our CVDs are there depicted. There's people who can give you some help on how to apply security in all of these different areas. Okay, so come up and visit us. And if you have any questions, Robert and I are present there today, tomorrow, for much of the day. We do take a break, but come find us up there. Yeah, so I hope we got through.
Here's our email addresses.
There we go.
All right. And then also, by the way, I send out a monthly newsletter on security protections that we've created, incidents that have been going on, new vulnerabilities in industrial equipment. If you're interested in getting that as well, please let me know, and I would be very happy. And Paul and I both learned from you what your unique situations are, what your needs are, what we can do for you, helps us to deliver more for you. Please, if you have the opportunity, we'd love to hear from you. We appreciate your patience coming in early this morning. I know we ran over. Hopefully this was of some value, so thank you again.